In this video, we're going to be talking about lateral area, surface area, and volume. Now, I've got some simple definitions of what each are here. The lateral area, the word lateral actually means side. So that's going to be the area of the sides of a three-dimensional shape. It does not include top and bottom. So it's like taking a box and just working on the middle part of it, like cutting the flaps, cutting the top and bottom lids off, okay? The surface area is the exact same thing, except for it includes the top and bottom. It's an entire surface, the whole outside. So the side or lateral area plus the area of the top plus the area of the bottom. Volume, it's how much space it has inside. So it's like filling the three-dimensional shape with something. How much storage space do we have inside of it? So that's the difference between lateral area, surface area, and volume. Now here's all the shapes we're going to be finding lateral area, surface area, and volume of. Now, I want to point out that there's three different categories of these shapes that we're going to be talking about. The first category I call uniform shapes. The uniform shapes have a top and a bottom, and those top and bottoms are going to be identical, such as the cylinder. The top and bottom are identical circles. The cube, the top and bottom is identical squares, a triangular prism, the rectangular prism. Notice in all of these, the top and bottom are the exact same shape. It's uniform all the way up. Then I have what I call pointed shapes. The pointed shapes would be the pyramid. Notice it has the base, but then it comes up to a single point. The cone is another pointed shape. It has the circular base, but then it comes up to a point. And these are all going to have different formulas based on what shape they are. And then you have the by itself, you have the sphere over here. So the uniform shapes, the pointed shapes, and the spheres. So now let's talk about the actual formulas. And let's start with the formula for the lateral area, the area of just the sides. Now, a reminder that when we're talking about lateral area, it does not include the top and bottom. So therefore, if it's a uniform shape, all we're going to do is perimeter times height, pH. The cylinder, pH, the triangular pyramid, all these uniform shapes have a lateral area of pH. If it comes to a point, the lateral area, the area of the sides, and again, this doesn't include the triangular on bottom. It does not include the circle on bottom, just the sides. If it's a pointed shape, we're doing 1/2 times the perimeter times the L, what's called the slant height. We'll talk about that in just a second. The cone, 1/2 perimeter times the slant height. Now, the sphere is over here by itself because it doesn't actually have a base. A sphere doesn't have a triangular base or a circular base or a hexagonal base. The sphere is just a continuous shape, so the lateral area, and what we're about to do in a second, the surface area, is the exact same formula. And that's simply 4 times pi times the radius squared. Is going to be how you find the lateral area. So if we understand that, the surface area is going to be pretty simple. The surface area is simply the lateral area, which we just did, the area of the sides, plus you got to add on the bases. So for a cylinder, you're going to do pH for the lateral area. Then you're going to find the area of the top and bottom and just add those on. Cube the same way. You're going to find the lateral area. Then you're going to find the area of the top and bottom square and add those on. For a pyramid, the 1/2 PL, you're going to find the lateral area, and you got to be cautious because it only has one base. So you're going to find the lateral area and then add that one base on. Same thing with the cone. You're going to do 1/2 PL, 1/2 times perimeter times the slant height, and then you're going to add on the circular bottom. The sphere, we've already said, its surface area is the exact same thing as its lateral area. Now let's talk about volume. In order to find volume, or the amount of space inside of these shapes, we're simply stacking area. So what I mean by that is for this cube, we're going to find the area of the bottom, and however tall that cube is, we're going to stack those areas on top of each other, stacking areas. Same thing goes for cylinders, triangular prisms, cuboid, or what we call rectangular prisms, or any type of prism. We're finding the area of the bottom and stacking however tall it is. Pyramids and cones, the pointed shapes, slightly different. We're going to do the exact same thing, find the area of the bottom, multiply by how tall it is. But then for both of these, you divide your final answer by 3. Find the area of the circle, multiply by how tall it is, divide by 3. Now, the volume of a sphere, we have a really odd looking formula here. It's actually equal to 4/3 pi r to the third. Or what I like to do, I actually like this version of the formula better. 4 pi r to the third, and then divide your answer by 3, because it reminds me a whole lot more of this pyramid and cone formula then. So 4 pi r to the third, which reminds me a lot of its lateral area and surface area, which was 4 pi r squared. So 4 pi r to the third, and then divide the answer by 3. Now let's actually work some examples of each. So let's start with a prism. Again, a prism is a uniform shape, meaning the top and bottom bases are identical. Now, one piece of advice that I would like to give, I always like to come over to the side and actually draw that base. And by the way, I'm going to let all my units be feet, just so that I have constant units on all these problems. So, but the problems should give you the units. So first thing we're going to do is we're going to find the perimeter and the area of the base. To find the perimeter of the base, you simply add up the sides. That's going to be 18 feet. That's the distance around. If you don't remember the area of a triangle is actually 1/2 times base times the height, which will actually be 12 square feet. Now, to find lateral area, surface area, and volume, we've done all the hard work. To find lateral area, again, anytime it's a uniform shape, you're simply going to do the perimeter times how tall it is. The perimeter we just found was 18. The height of the entire three-dimensional shape is 10, so 18 times 10. The lateral area, and since it's in area, it's going to be in square feet. That's 180 square feet. Again, that's how many squares that it would take to cover, right next to each other, to cover the sides of this shape. To find surface area, it's the previous answer, but we have to include the top area and the bottom area, which we've actually already found. The area of the top was 12. The area of the bottom also 12. So when we add those together, we get 204 square feet. To find volume, we simply stack areas. So if you remember the area, we found it up here again, 12. And you simply have to ask, how high do you have to stack it? And that's going to be whatever the height of the shape is, which is 10. So your volume is going to be 120 cubic feet. And that's all you have to do to find the 3. Okay, let's do another uniform shape. This is called a cylinder. Again, I like to come over to the side, and it doesn't have to be a great drawing, obvious. Come over to the side and sketch the base, the top or bottom, which is a circle here. We're going to find the perimeter and the area of that base. Now, we know that the perimeter of the base has a special name. It's called circumference. The distance around this, now the formula for circumference is pi times whatever the diameter is. Since the radius is 3, that means all the way across will be 6. So pi times 6, we're going to leave a 6 pi. And again, we're going to let everything be in feet. To find the area, you're going to square the radius and multiply by pi. So pi times radius squared, so that's going to be 9 times pi. And that's going to be in square feet. And again, that's the hard work. That's the hardest part. Find lateral area. Again, it's simply pH. The perimeter times how tall it is, which is 6 pi times 8. Just multiply the pieces that you can. 6 times 8 is 48. Leave the pi alone. And that's going to be the lateral area. That's in square feet. To find the surface area, it's the exact same answer. But you have to include the area of the top, which we've already found was 9 pi. The area of the bottom, which was also 9 pi. Since they're all pi's, you can add them together. They're alike. And that gives you a total of 66 pi's. And that's going to be also in square feet. So that's the surface area. The sides, the top, the bottom. To find volume, again, we're stacking areas. The area of the top and bottom is 9 pi. And now we simply have to ask, how high do I have to stack it? The height of the shape is 8 feet. So therefore, multiply what you can. That's 72. Leave the pi alone. And that's going to be in cubic feet. There's the volume. Okay, next up, let's actually do one of our pointed shapes. Let's do a pyramid. And again, since it does come to a point, it's got a different formula. Now, also, something we need to discuss is, what do we mean by height versus lateral height or slant height? The slant height is actually the height down a side. And notice kind of it's going down at a slant. And here in a second, we'll show you the difference, or where the slant height, how it's related to the actual height itself. The height itself goes from the top straight down to the bottom, to the center of the bottom. Now, another point that I need to make here. The formula that I'm about to give you only works for equilateral things. The bases have to be equilateral, meaning it has to be an equilateral triangle. It has to be a square. It has to be something to where the bottom, all the sides are the same, okay? To where you have a center point pretty much on that bottom. So first off, again, I've drawn my figure over to the side. I didn't have enough room to actually put the full root 3 on that. So let's do perimeter of the bottom. and let's do the area of the bottom. Perimeter, just add up all the sides, and you get 24. The area, since it is a triangle, is 1/2 of the base times the height. 1/2 of the base is going to be 4 times the height is 4 root 3. Multiply what you can, and you get 16 root 3. And that's going to be in square feet, since we're letting all of our units be feet. Okay, next up, here's your formulas. Lateral area, surface area, volume. In order to find the lateral area, since it does come to a point, you have a new formula, 1/2 P, let's try that again, 1/2 PL. 1/2 times the perimeter times the slant height. And again, the slant height is simply, I gave it to you over here instead of drawing it on the figure. So it's going to be 1/2 times the perimeter, which we found to be 24, times the slant height, which I said was 6. Half of 24 times 6 gives you a total of 72, and that's in square feet because it's area. To find the surface area, we're simply taking that previous answer. Now here's one thing that's slightly different. We only have one base. The lateral area gave me the area of those 3 sides. The area of that base we found up here was 16 root 3. You can only add things that are alike, so we're going to leave those separate. So you could turn everything into a decimal and get a decimal answer, but we're going to leave it as 72 plus 16 root 3, and that's in square feet as well. To find volume, again, we're stacking the areas. So we have an area of, let's go back up here and look. You had an area of 16 root 3. You're going to stack it. Now we're talking about the height now, straight up. You're going to stack it 5 high. Now also a reminder, anytime it comes to a point, your volume you divide by 3. Multiply the pieces that you can multiply together. 16 times 5 is 80 root 3s. If you can divide this, you can, but 80 divided by 3 is going to give me a decimal, so I'm actually just going to leave my answer right there, and that's going to be in cubic feet. Also, again, you can turn everything into a decimal. If you wanted to actually plug in root 3, turn it into a decimal, you could get a decimal answer for this also. Okay, guys, now we have a cone. A reminder again, a cone is a pointed figure. Over here to the side, you see that I have the base drawn, which is a circle. So let's first start out talking about the perimeter and the area of the base. Again, feet is our units here. So to find the perimeter, the distance around a circle, again, it's pi times diameter. Since the diameter is 6, that'd be 6 pi. And that, again, is in feet. The area is going to be pi times the radius is 3. Since 3 times 3 is 9, that would be 9 pi. And that is the area of the base. That would be in feet squared. Now to find the lateral area, the surface area, and the volume. Lateral area, again, since it comes to a point, your lateral area is 1/2 PL. We do see here, let me point something out about the L. You can kind of see here what the relationship between the slant height and the actual height is. Notice the right triangle. The actual height from the top straight down to the bottom would be like a leg of a right triangle. The radius would be the other leg. And that slant height is kind of like the hypotenuse of that right triangle. So we do 1/2 times the perimeter. Again, the perimeter was 6 pi. Times the slanted height, which is 5. Multiply what we can. Half of 6 is 3. 3 times 5 is 15. So our lateral area is going to be 15 pi. Leave the pi alone. And that is, again, area, so it'll be in feet squared. Surface area, we're taking that exact same area. We're adding on the base. This only has one base. We have the area up here, which is 9 pi. Those are alike, so we can't add them. So that's going to be a total of 24 pi. And that's also in square feet. That's going to be the area of the side, the lateral area, and the bottom combined. So that's total surface area. To find the volume, again, we're stacking area. So we got an area of 9 pi. That's the bottom. We're going to stack it straight on, so make sure you go by the regular height. And since it does come to a point, we're going to divide it by 3. So multiply and divide what you can. 9 times 4 is 36. So divide it by 3, it leaves you 12. Don't forget your pi. And again, that's going to be in, since it's volume, cubic feet. Okay, our last shape here is a sphere. And just a quick reminder that a sphere has no base. So therefore, the lateral and surface area is going to be the exact same formula. And that's simply 4 pi r squared. The only measurement that you're really going to have is with a sphere is going to be that radius. So therefore, we're going to square the radius. So that's going to be 4 times pi times 2 squared will also be 4. Multiply everything that you can. 4 times 4 is 16. Leave the pi alone. And also a reminder, that's the lateral area as well. Lateral area and surface area are both equal to 16 pi, and that will be in square feet. The volume, can't really stack areas here, so we have a special formula. I said it was 4/3 pi r cubed. But to make it look like this other formula, let's do instead 4 pi r cubed and divide the whole thing by 3. You're going to get the exact same result. But the top looks so similar now to the surface area formula. So the volume is going to be, we're going to plug in the 2, raise it to the third power, which simply means 2 times 2 times 2. So it's going to be 4 times pi times 8. Divide the whole thing by 3. Multiply what you can, divide if you can. That would give you a decimal, so we're just going to leave it as 32 on top with the pi, the 3 on bottom, and since it was give us a decimal, we're just going to leave it like that. Now, if you would like to, you could plug in 3.14. You could divide the whole thing by 3 and give the decimal answer, but that is going to be in cubic feet.